Hello, welcome back to the data structures and algorithm video series. In this video we are going to cover arrays. So we will see one example of an array using C++ and also big O notation, how to find the efficiency of an array by using big O notation. So this is going to be the agenda. So we will talk about the arrays and we will also find the efficiency using big O notation. Introduction. Array is one of the data structure. Arrays are series of memory location with a single name. Just to have an introduction, in a computer memory we have series of location. See, this is a location and this is a memory location and this is memory location, like that it goes on. Okay. If you declare a variable called as a, like example I have integer a here. Okay. A is a variable name given to a location which can store integer value. Okay. Or the location of integer type. So it is going to allocate a location in the memory of integer type, which means that it can store integer value. So in the above example you can see there are series of memory location, but only one memory location is allocated for a. So which is of type integer. So this is going to be a normal declaration of a variable here. So how do you declare an array? Now how do you declare an array? So array can be declared as a of phi. So when I say a, open bracket and close bracket, square brackets, within that square brackets if you have phi, which means that we call it as a of phi here, and before that we have integer, and this a of phi is declared as integer here. So what is the meaning of this one? Whenever I say a of phi, okay, there will be 5 memory location allocated to this a. Okay, all these 5 memory locations will be accessed by using the name called as a. Okay, and each and every element in these 5 locations it can store integer values. Okay, that is what is the meaning of this one. When I say integer a of phi, it is basically 5 elements, 5 series of elements in the memory is allocated for this a, and all the 5 elements are going to be of integer type. So that is what is explained here. We have a variable name called as a, and within the square bracket we have 5. Okay, and it is declared as integer. So here we have set of 5 locations, and the name given to all the 5 locations is going to be a. Also we have 0 to 4, which is called as index. Okay, so you have a here for each and every location here. To differentiate the first element, second element and third element, we have something called as a number which starting from 0, which is called as index. So every memory location is accessed by the name and the index. Okay, so we can store 5 integer values in the above array. So based on the type, whatever we declare. So if you declare as a character a of 5, which means I can store 5 characters in each and every location, one by one we can store. Okay, since it is declared as 5 integer values, 5 a of 5 here, you can store 5 integers in this particular array. Each and every location can have one integer value. Okay, so this is going to be the array declaration. Okay, So how do you access every location here? As I already told you, this location can be accessed by using the name, at the same time the index number. 0, 1, 2, 3, 4 are called as index numbers. So by using this name and the index number, we can access every location here. So that is what is explained here. Like if you say A of 0, it is going to be the first location, A of 1 is going to be the second location, and likewise it goes on. So here we have A, and the index for this particular location is going to be 0. So A of 0. So when I say A of 0 is equal to 10, which means that 10 is put in this particular location here. Similarly, A of 1 is going to be this, A of 2 is going to be this location, A of 3 is going to be this location, A of 4 is going to be this location. So if you want to store any value in any of the location, we have to use the name. At the same time, we should also use the index number, and then you can say equal to 10. So why do you say 10 here? Because 10 is an integer, and we have declared A of 5 as an integer. So we can store in every location we can store one integer. Okay. So here is one example. Let us see how this particular example works. In a main program, you have integer num of 5, which means that I have, according to this, now here the name is given as A, but in the example the name is given as num. So it is going to be num, and we have indexes from 0 to 4. Why 0 to 4 here? If it is 5, since it is starting from 0, it is going to be 0, 1, 2, 3, 4, 5, which means it is going to be 5 elements here. But always the first element is going to be starting with 0, the second element will be 1, third element will be 2, fourth element will be 3, and fifth element is going to be 4 here. Okay. So if I wanted to take 5 elements and store it in one particular array, then I can follow this number, I can follow this one. I can declare integer num of 5, and num of 0 is equal to 10, num of 1 is equal to 2, num of 2 is equal to 3, num of 3 is equal to 40, num of 4 is equal to 50. So like this I am going to store the values here, and see you can see that one, since it is the index value is starting from 0 to 4, and that only varies here, but the name is going to be same. Okay. So an array will have the same name for all the locations, whatever locations we assign. For all the location, name will be same, the index number will differ. So we can use a for loop for executing, or we can accessing that array, you can use a for loop. So here I am using for integer I is equal to 0, I is less than 5, I plus plus. I am displaying each and every number in an array here. Okay. So we can see this example in a C++ IDE. Okay. So I am going to use an IDE which is available on the web. Okay. So what we will do is, we will go to the browser, IDE 1, you have IDE 1, just click on this IDE 1, you can see this is the IDE 1 which is given to us for writing a code, and we can compile that. Okay. So you can write any type of language you can write here, and you can compile that, and you can see the result. So since we are taking C++ example, what I am doing, I am selected C++ here. Okay. And this is going to be for running it, and here is the editor which is going to be given to us, and a basic program, a standard program is given to you here, and we can add our code here in this place. So let me explain you by just expanding this. So there is a standard program which is given to you here, and you have a main and you have an empty main function here, and you can start writing the code. So as I was explaining you, I can just say integer num of 5. So here is a declaration of an array. So you can declare an array like this. So integer num of 5. As I told you, there is a single name num is given to set of 5 locations, okay, and each and every location can be accessed by the index number, and the index number always starts from 0. So how do you do that one? If you see num of 0, it is going to be the first element. I am assigning this one. Assigning here, what I am doing, I am assigning 10 to this num of 0, which means that first location in the array. Here if you look at this one, first location in the array, I am assigning 10. Same way the second location, I can do that by using num of 1 is equal to 20. Same way I can assign the other values also. 2 is equal to 30, num of 3 is equal to 40, num of 4 is equal to 50. So if you look at this one, there are 5 elements here, but only the index is starting from 0 to 4. So I am saying 0, 1, 2, 0, num of 0 is going to be the first element, num of 1 is going to be second element, 2 is equal to num of 2 is third element, num of 3 is fourth element, num of 4 is going to be fifth element here. So for storing this, for storing any value, I can use this method. So here I have used assignment. I have just assigned the value, since it is going to be a very small array and it has only 5 elements. I have just assigned the value here by just saying num of 0 or num of 1 is equal to 10 or 20, like that. But if you wanted to accept the value from the keyboard, you can do that, or if you wanted to load the array by reading a database, you can do that one, okay. But every time whenever you do this one, for every location you do one operation. So this is going to be first operation, okay, and the same operation is going to be repeated here for the second time, third time, fourth time and fifth time. How many times it is going to be executed here? 5 times it is going to be done. So this is going to be operation 5. So after the end of the fifth operation, I have loaded the full array here, okay. So this is a very small example, and this is going to be a very simple one. How do you load the one? How do you access it? As I have already explained you, I will be using a for loop, because here the num is not changing, the variable name is not changing, only the index number is going to change, okay. So let me use a for loop for displaying it. For integer I is equal to 0, I is less than 5, I plus plus, and within this cout I will say num of I. Again I will just give a space here, so that we will see a space between each and every number when it is displaying. So this for loop, it starts from 0, num of 0 is going to be displayed here first time, okay, then it is incremented, then again it goes to num of 1, incremented, num of 3, like that, till this condition is satisfied, okay. So this is going to be a very small program which will explain about the array data structure, and this is going to be for the store, and this is going to be for the display, okay. So let me run this program and show you how this is going to be executed. Just run this one. You can see that it is compiling and it is going to give you the output. So you see that output is going to be first time 10, 20, 30, 40 and 50. So you assign the values by using assignment operator, and you can also display it by using this. So this is a very small example to explain the array data structure. Okay, so let us go to the slide now. We'll close this. Let us go to the slide. So this is what we have done in the program. Now let us see how this array is efficient, or how do you calculate the efficiency of these arrays by using big O notation. So in this example of arrays based on big O notation, let us take 4 parameters. We have already seen that big O notation will have 4 parameters. One is going to be one is going to be store, second one is going to be search, third is insert and delete. So we need to see the number of operations for each and every parameter. I have already told you there are some operations which when I was explaining you the program, I told you about that every element whenever I wanted to load it, I need to do this operation, that is equal to assignment operation, I need to do it, or I have to say equal to 10 or equal to some values here. Okay, so let us see what are the set of operations which I need to perform for each and every parameter here. Okay, so let us take this example, this one, and we have already seen that for storing an array, for adding every element in an array, on the store operation is done. Okay, so if you look at this one, I have declared this integer num, and num of 0 is equal to 10, num of 1 is equal to 20, like that. So let us take the same thing to understand or to find out the efficiency of big O notation here. So let me go to this one, IDE 1. So here I will declare integer num of 5. So now I am doing store operation. Here what I am doing for every element, so when I want to store the first element, I need to say num of 0 is equal to this operation, I need to do it, and the value should be assigned at the end. Same way I need to do for the second element, num of 1 is equal to 20, and similarly num of 2 is equal to 30. So num of 3 is equal to 40, and similarly num of 4 is equal to 50 here. Look at this one, for storing one element I need one operation. So this is the first operation 1, and for storing the second operation, second element, I need again one more operation, similar operation I need. This is operation 2. So like this it goes up to n operations here. So if I have n is basically the number of elements in an array here. If I have 5 elements, I need 5 operations to store the full array. This is going to be operation 5. So if you take this example here, for storing every element in an array, I need one operation here. So if I want to store one element, I need one operation. If I want to store 3 element, I need to have 3 elements. Okay, and if I want to load 5 elements, I need 5 operations here. Now let us go to the slide here. For storing an array, we need all the 5 operations here. So, same way what I will do is, this is going to be an example. Let us understand the concept like this. See, if I want to store every element, I need one operation to be done. This is in storing of an array. Let us take insert. Inserting an array. For inserting an element on the top of the array, we need to do 5 operations. How do you do that one? So let us look at this one. In the example here, in this example, let us not do this one first. So I have loaded 4 elements, that is num of 0 is going to be 10, num of 1 is equal to 20, num of 2 is equal to 30, num of 3 is equal to 40. Okay, and the fourth one, that is the fifth element, is empty and I am not assigned any value here. If I wanted to insert the fifth element, I need to do one more operation. So like for example, if I wanted to do the fifth element, I am talking about insert now. If I wanted to do num of 4 is equal to some value I wanted to put it. If I want to do only the last element, I need to add it, or I want to insert the last element, then I need one operation here. But I will say this is the last element. If I wanted to insert the last element, I need only one operation here. Okay, so based on this particular example, or based on this particular scenario, I cannot say number of operations required for insert is only 1, because always the insert is not going to be inserted only at the end. It is going to be inserted, it can be inserted anywhere else also. For example, now I wanted to insert the value at the beginning of the array. Okay, so the array is having 5 elements, out of that only 4 is been loaded here. So what I need to do here, I wanted to insert at this point. I wanted to insert at this point. But if I wanted to insert at this point, this value should be, these values, all these 4 values, that is 10, 20, 30, 40, should be pushed towards down, which means that number of 4 is equal to 40, num of 4 is equal to 40, num of 3 is equal to 30, num of 2 is equal to 20, num of 1 is equal to 10. Then I have a value here which can be inserted in num of 0. How do you do that one? So it is again, first what I will do, I will say num of 4 is equal to 40, num of 3 is equal to 30, num of 2 is equal to 20, num of 1 is equal to 10. If I do this one, what happens here? From 1 to 4, that is num of 1 becomes 10 here, num of 2 becomes 20, num of 3 becomes 30, num of 4 becomes 40 here, and num of 0 is right now available for inserting. So a new number can be inserted in num of 1, num of 0. So I can just insert 5 here. So this is actually the new inserted element, inserted value. Okay, so for inserting on the top of the array, which is going to be num of 0, what I did, I have done this swapping the number from 3 to 4, 2 to 3, 1 to 2, 0 to 1. So how many operations I have done here? This is one operation, this is second operation, third operation, fourth operation, and then the insert is also happening. So 5 operations I have done here. So when I wanted to insert the value, it is going to be the first value, first element. When I am inserting in the first element, I need 5 operations. When I am inserting in the last element, I need only one operation here. Okay, so this is about insert. This is about the insert here. So remember that you need only one operation for inserting at the last, and you need 5 operations for inserting on the beginning. So this is about inserting. Now let us go to delete. Deleting an array. So if you are going to delete the top element in an array, we need to do 5 operations. If you are going to delete the last element, then it is going to be only one operation here. So this is going to be the same way how we are going to do it, how we did it for insert. So if I am going to delete, say of 0, num of 0 is 10. Now this is actually the top element, delete the top value here. So the last element will become a 0 here. Okay, like example here, this is what is the insert we have done here. This is what is the insert here. This is the new insert. What I want to do is I wanted to delete the first number, that is num of 0. So what I will do, deleting an array, deleting an element. So when I am deleting an array, when I am deleting an element, okay, on the top, okay, so what I am going to do, if I delete the last element, I mean the first element, the second element should come on the top, third element should come to the first one, third one should come to the second one, and first element should come to the 0 1, and fourth element should come to the third element, and fifth element should come to the fourth element here, which means that when I want to delete num of 0, I will have to say num of 0 is equal to 10, and same way num of 1 is equal to 20, and same way num of 2 is equal to 30, and then num of 3 is equal to 40. So first element you have removed it, the remaining 4 elements you shifted one step above, and the last element will be 0. So we can do this deleting like this by using assignment operator, by using just manually you can do that. Num of 0 is equal to 10. So here number of 0 was 5. I am deleting this one. Okay, when I am deleting this, I am just going to put this 10 on the top, 20 here, 30 here, and 40 here, and this one is going to be, this is the last element, it becomes a 0 here. So this can be done by using a for loop also. So that is what I have explained in the delete element here k2 for k is equal to 0 and k is less than 5 and k plus plus, and if I just say num of k is equal to num of k plus 1 and the last element I make it as 0 here. So you can also use a for loop for this. Okay, so now you can just see the for loop. So I can do the same deletion by using for loop. For integer k is equal to 0, k is less than 5, k plus plus. So here you can just see num of k is equal to num of k plus 1, and then at the end of this array you can just say num of k is equal to 0. So at the end of this one it is going to be 5, I mean the fifth element, so that fifth element I am making it as 0 here. This is what I have done it manually here, and this is what is going to be the for loop for doing this job. Okay, so you can delete an element. So if I want to delete the first element, again here we need to consider is, if I want to delete the first element, 5 operations I need to do it. Okay, but if I want to delete the last element, I need only one operation. Okay, so keep that in mind, and then we will go to the next one. Searching. Okay, so in searching, we in an array, for example I have this array here, I have an array here, there are some values here 10, 20, 30, 40, 50. Okay, if I wanted to if I am searching for a number which is available in the first location itself, then number of operations which I need to do is only 1. Okay, but if I wanted to search the number which is available in a of 2, I need to do first operation, second operation, third operation, 3 operations I need to do it to search this. Similarly, if I have the last one, if I am searching for a number which is available at the end of the array, then I need to do the first operation, second operation, third operation, fourth operation and fifth operation here. So in an array of 5 elements, I need to do 5 times to search the last element which is available in the array. Okay, so that is what is explained by using this for loop here. Wherever the number is found, that number when it is becoming 0 here, and I'm going to come out of this. So basically what I am doing is I am just having an number array here like this. 0 is 10, num of 0 is 10, num of 1 is equal to 20, num of 2 is equal to 30, num of 3 is equal to 40, and num of 4 is 0. So I am searching for a 0 here. Okay, search for 0 in an array. So if I have for I is equal to 0, I is less than 5, I plus plus, and if the num of I is equal to 0, then I will break from that. When I come out of this one, number of times I was there in the search loop will be the number of operations which I have performed. Okay, so if I want to do the first element search, it will be 0, only one operation. If I wanted to search the last element of an array which is having 5 values, then it is going to be 5 times the search loop will be executed. So the number of operations is going to be performed is 5. Okay, so the same thing can be explained by using this for loop here. So for integer j is equal to 0, I am searching here, I am going to search for 0 here, 0. So 0 is available at the last element here. According to the last operations whatever I have done here, it is going to be like this. Even after this particular for loop also, it is going to do the same thing. For I is equal to j, for int I j is equal to 0, j is less than 5 because I have 5 elements in that in an array and j plus plus, and inside this, sorry, inside this one, inside this I am going to have if num of j equal to 0, because I am searching for this one. Whenever it becomes 0, you come out of this one. Okay, break. So at the end of the loop, what I am doing is I am going to say cout. I am going to say cout. I will say number of operations instead of saying number of search loop. I will say number of operations performed is the number, actual number. The actual number is available in j here. Okay, so let us execute and see here. Let us see how we can execute and see the result here. We just run this application. So it is running here. So there are some a declared in the scope and number of k within this. Okay, let me declare this k on the top. Just go for edit and declare k on the top, I, j, k. All three variables, whatever I am using it in the for loop, I will declare it on the top here. And same way here also I have not used, I have used I have not used I here at all. Okay, so j also is declared on the top. Okay, so this is the compilation error which is coming here. Now save this and then run it. So now it's compiling now. So number of operations performed is 3. Okay, so here what I have done is I have made this number of 0 if is equal to 0 0, then break, and then you go for the loop. The number of operations is going to be 5 here. So let us display and see what is the value which is going to be stored here. For I is equal to 0, I is less than 5, I plus plus. So I am going to say, I am going to display the value here. After this operation, I wanted to see what are the values which is stored in the array here. Cout num of I okay, then here I can just put one slash n so that it comes to the next line. So now I will save this and clear the output and then run this operation. So what is the problem here? Int main error, and it is just before this one. Okay, there is a semicolon which I missed it. Now I will save this and run it. Okay, so here it is, actually it is 3, so it is, that's why it is giving this one. So it is not stored properly here. Okay, so the last one is not stored properly in this particular thing. So k of 0 is 0 plus 1, first element is coming here, second element is coming here, third element is coming here, fourth element is coming here. Okay, so this is the problem with this loop. Let me avoid this loop now. We can form the loop also and see how this can be the inserting or deletion can be done. Okay, so now if I am running this one, clear the output and run this. So now here you should look at this one. This is going to be 10, 20, 30, 40, and last element is going to be 0. So that index number is displayed here. So when j is equal to 4, that means num of 4 is the last element, so it is displaying the last element here. Okay, so you can search by using this one. But if I am searching for 10, for example, if I am going to search for 10 here, so what is going to happen here? It is going to be 0th element. So it is going to be the 0th element here. So here if I want to do one number of operations, okay, let me put just for explaining the number of operations, I will give j plus 1. Okay, and we will see what is going to happen now. If I am searching for 10 here, it is going to be 10, 20, 30, 40. Number of operations performed is going to be 1 here. Okay, and I will clear this, and I am searching for the last element, and the last element is going to be 5 operations. If I am searching for the last element, and it is going to perform 5 elements here. Okay, so now coming back to the big O notation, we have seen how to insert, how to delete, how to store, how to insert, how to delete, and then how to search. Okay, so now let us go to the store. Okay, to store a value in an array, we need to do one operation for every element. So if I have n element available under the array, I need to do n operations. So according to the big O notation, it is O of n. Okay, searching. When I am doing a searching, just now we saw that when I am doing a searching, if I am searching for the first element, okay, it is going to be one operation only. If I am going to search for the element which is available at the end, then it is going to be n operations. And we have already discussed, if you have two outputs which is coming for when I am writing a code, we have to take the maximum value here. Here we have one operations, here we have n operations. We need to take the maximum one, that is going to be O of n. So searching also is O of n here. What about insert? Insert, when I am inserting the first element, it is going to be O of n, and I am inserting at the last, it is going to be O of 1. Okay, so here also two operations are going to be two outputs are coming, O of n and O of 1. So which will be considered here? It is going to be considered as the maximum one, O of n only. Same way for delete, we have again O of 1. If I am deleting the last element, it is going to be only one operation. If I am deleting the first element, it is going to perform 5 operations. So it is going to be O of n. So based on all these analysis, if you look at this big O notation, for storing, O of n is a big O notation, and so for searching, O of n, inserting O of n, deleting is also O of n here. In an array, these are all the parameters, and these are all the values for each and every parameter is O of n only here. Okay, so now having this in mind, and when we write different data structures, what we can do is we can compare these things with that. Okay, whatever is the big O notation for the second one, like for example, if I am going for a stack, for storing the in a stack, what is going to be the big O notation? We can compare the big O notations of both stack as well as an array. For an array, this is going to be the big O notations here. Okay, and in case if you wanted to concentrate on one or two parameters, for example, I wanted to concentrate on search. Okay, so you take the search big O notation, you need n operations here. In case if any other data structure for search operation it requires only one operation, then that will be more efficient than this particular array, because you are concentrating more on the search. Okay, so this is how we need to use our big O notation here. Okay, this is an example for the big O notation on an array. Okay, thank you. And in this video we have seen about introduction to array in C++ with an example, and how to find the efficiency of big O notation, okay, using the big O notation. Thank you.